Okay, in this video, we're going to take a look at inventory management. How do we manage that part of our business that, quite frankly, is where we get the assets in order to generate profits and cash flows? So there's lots of viewpoints about how much inventory to have. It's really a combination of lots of different departments, right? So financial managers want to keep inventory low, obviously because it ties up cash. Marketing managers like to have lots of inventory. So anytime they want to sell, it's ready and available to go. Manufacturing managers, really, they obviously have to produce products, manufacture them, so they want to make sure that they have enough, an acceptable amount of quantity and quality in order to provide the products that the company is going to sell. And of course, the purchasing manager is concerned solely with the amounts of raw material inventories. So there's lots of competing views on how much inventory we need. And obviously the company needs to figure that out, right? We have to understand that. So one of the techniques we have is something called the ABC technique. And essentially what this is it ranks products in order of the descending order of importance, right? So group A are typically those things that have the largest dollar investments. They're really a smaller part of the number of items we have in our inventory, right? So it's about 20% of the items, but about 80% of the actual inventory, right? So few items, large dollar amounts. We really want to control those. And since we have such few, we really have to pay attention to the amounts we have so that we don't run out. B obviously is the next level down, and then C is at the very bottom, has the greatest number of units, but has the least amount of dollars tied up in it. So again, the large dollar investment in A and B suggests we need to have a better management than this ABC system, right? So we designate ABC, and then we decide how are we going to measure the A and B? How are we going to manage that? And we manage that through a process of something called the economic order quantity. Now, this is a technique for determining the item's optimal order size. That's the size that minimizes the total of its ordering and carrying costs, right? So the idea here is we need to figure out how much stuff we need to order when we order so that we can minimize the costs of placing orders, right? So we have people working, we got to pay them, right? There's administrative costs associated with ordering things. And then we have carrying costs, right? So those are things like, maybe we have inventory, we have space requirements, etc. So order costs are fixed clerical costs and carrying costs are variable, right? Every time you place an order, it costs X number of dollars. It's fixed. But once we receive that, the costs we have are dependent on how much we have. So it's variable. The economic order quantity is a very basic formula, EOQ down here. We have the order cost. What does it cost to place an order? S divided by Q, right? S, that's how much we're going to use of the product. Q is the order quantity. So that's what it costs. You take the ordering cost times how many times you place the order. Carrying cost, that's C, that's the cost per unit, and then you divide that by the average of the units that you have. So the total cost, EOQ, right? The total cost is the order cost plus the carrying cost. Now we want to solve for the order quantity that's going to minimize the total cost. So quite frankly, it is a calculus equation. So when you determine the derivatives, this is the formula that you would see. The economic order quantity is 2 times the sales units times the cost per order. You divide that by the carrying cost per unit. That will provide us with EOQ. So the reorder point then is this point at which you actually need to place the order. Now this is going to be expressed as days. So the reorder point is the days of lead time. How long does it take to get the product, multiplied by the daily usage. So this means we won't run out of stock, plus some safety stock. So again, this is just the time that expires from order to receipt, right? So we need to have an understanding, right, of how long it takes to get the products in. And again, since they're not precise, again, that's the reason for this safety stock. We want to make sure we do not run out of important items. Again, A and B are bigger things dollar-wise in general, and they may be things that are a little difficult to acquire, to have shipped, to receive from whoever our suppliers are. So here is a company, has a group, an A group inventory item, right? So it costs $4,000. It uses 3,000 units per year, and they want to determine the optimal order strategy for the item. So to calculate EOQ, we need the following things, obviously. What does it cost this company to place an order? They've determined that every time they place an order, it costs $500. The carrying cost per unit is determined, and that is $650 per year per unit. So what is EOQ? The formula, 2 times the 3,000 units times the 500 order quantity divided by the $650 cost per year, says we need to order, when we order 67.94 units. Of course, you can't order a part a unit, so you would assume that this is 68 units. So what's the reorder point, right? When do we have to place these orders? Let's assume that they operate 200 days per year, and they use 3,000 units of this item. Divide the 3,000 by 200 days. That means the daily usage is 15 units. If its lead time is 3 days and we need 4 units of safety stock, what's the reorder point? Is 49 units, right? So it's 3 times, here's the 3,000 units per year divided by 200 days. That is our 15 units plus 4. So 3 times 15, 45 plus 4, 49 units. So the reorder point for this item, when we get to 49 units, that is when we place the order to get this this particular asset. And of course, using a worksheet, there's a worksheet available. Plug in the data that you know, and then in the end here, you see down here, here's the reorder point, $49 or 49 units is when the reorder point works, or when the reorder point is supposed to happen. So here we have an example. So how can we work this example? And I'll leave this up to you. Open the worksheet. Um, in the notes section of this PowerPoint, you will find the answers to this particular problem for EOQ. So work your way through this unit, find out the reorder point, find out the order quantity, the required order quantity, and the reorder point for this particular investment. Another type of inventory technique is something called just-in-time. And this minimizes the inventory investment by having materials arrive at exactly when they are needed for production. So the objective here is to minimize inventory. So there's very little, if any, safety stock. It's going to take a lot of coordination to understand how this works together. So obviously, if you can't get the material on time, then the production line could shut down, and obviously you won't be able to produce anything until the materials arrive. So even though just-in-time minimizes inventory, it requires a lot more coordination and effort by management and employees to make sure we don't run out of product. So we're going to need lots of product coming all the time, and we're also going to have to make sure that it's high quality, right? So if you get a batch of things that are not such good quality, then how are you going to manage that, right? What are you going to do to get rid of that so that we can get better quality parts in? So that in itself could create a shutdown of the production line, which is obviously something we do not want to do.